Wasabi, guys. I'm going to show you the fastest and cleanest way, and I want to thank my friend Anad for showing me this. The habit of utilizing fractional parts. It takes a lot of experience, but we're going to do something a little sneaky. So I'm just going to go right ahead to this position, right? Okay, so here, now we utilize this fractional part, we just turn the whole thing into a summation. However, there's a cleaner way. What we're going to do is we're going to take advantage of if you remember the periodic rule, where if you have an integral full of fractional parts, right, then this is going to equal to a times 0 to 1 of f of x, right? Because fractional parts are periodic, okay? Fractional parts are periodic at 1, so we can utilize this periodic formula here. It's an integral property, actually. For any periodic function, it works just like that. And that's what we're going to utilize. Now, how do we apply that here, right? Because we have a u here. What we're going to do, we know that the fractional part is equal to u minus the floor function of u. Then u is equal to the fractional part plus the floor function of u. So that's what we're going to do. So now we have two there. So now we have the fractional part squared, and then plus a floor function and the fractional part. Okay, this is awesome. Here we just use the periodic. Okay, this is 90 0 to 1 x squared. All right, cool. Right, but what do we do here? What do we do here? Think about it. Is this any better than this? If you think about it, is this integral better than this integral? Yes, and let me show you why. First of all, I just want to take this out. This is what, 30? Okay, so this is just power rule, so that's equal to 30. This is actually a lot better than this, and let me explain why. Here, if I show you, when we turn it into a sum, okay, when we turn it into a sum, we're gonna get n plus 1. However, this floor function, it's technically a constant. Does that kind of make sense in a way? Here, when we see this portion here, that's not a constant. Here, we have a u, a variable, so we had to actually integrate with it, right? That's the only difference. Here, this is technically a constant, and the reason why I say that is because when we turn it into a sum right here, what is this now? This is just n. That's just a constant now. Here we have the fractional part is u minus n. Do you see the difference now? Right? Here, that's not a constant. Here, that's technically a constant. I know it's a floor function, but when you turn it into a sum, it's a constant. So you're only left with fractional part. Here, we can't do that. We have this u, and we have to integrate with the fractional part, which is why our sum was nasty. So, here, this is good, because now, what is this? U minus n? Psh, easy. Let w equal u minus n. What you literally have is 30 plus the sum of 44, n equal to 0 to n, from 0 to 1 of w dw. That's literally it. That's literally it. If you let w equal u minus n, your bound just goes to 0 to 1. Because that's how fractional parts work. It's periodic from 0 to 1. So, here, This is so much cleaner, right? It's so much cleaner. Now this is just the answer, just 30 plus just the arithmetic sum from n equal to 0 to 44. So now we have 30 plus what? 22 times 45, right? Which is the same thing as 11 times 90. This just helps me calculate much faster. So now we have 990, 30. This is like what? 1020. So that our answer is 1020, and this is how you get a nice clean integer. Now, obviously, the sneakiest thing was this part here. Okay, this is not intuitive. This is not intuitive. This part here, okay, turning this into this is not intuitive. This is the most sneakiest part here. That's not something that we usually do. But now you know. Okay, so now you know from learning from this integral. Okay, if whenever you see something like this, right, turn these in terms of this, so that now you get everything in terms of this. This is better than this, because here you still have to integrate and you get nasty stuff. Here, this floor function is technically a constant. So you could just, when you turn everything into sums, you move it to the front, and all you had to deal is this, right? Oh, but wait, that's just a fractional part. So technically this goes to here. Yes, it does, right? I just want to show you step by step so that no one gets lost, because this is going from here to here is a little difficult for us to see. So, but yeah, the whole mechanism is because of the u sub here. All right, so that is the fastest way, the cleanest way to solve this integral. Okay, very sneaky. This part right here is very sneaky, but definitely keep that in mind. If you have a mixture of u and fractional parts, this is probably the best way to go if you want cleaner answers. Okay, so in that way, this is just a constant when you do the summation. Okay, all right. I hope that helps. Thank you guys so much for watching, and I'll see you guys in the next video.